belongs to Taylor Francis, Springer and Scopes. 26 academic events and is a member in Board of Management, Academic Council, Board of Research, Research Monitoring Board, Equivalence Committee and IPSC of Amit University. And he in national and international conferences. And he has completed the guidance of 3 Ph.D. scholars and 4 MPhil scholars since 2010.
Listed here are some of the minerals and fossil fuels and precious stones that are mined from the soils of India. Approximately 3 lakh hectares of land are subjected to mining in India. So Linnett Corporation is an Avatra company involved in the fossil fuel mining, especially lignite. And the lignite occurs at 80 feet depth and it is excavated at 20 feet benches. And you can see the picture of the soil excavation in benches navally. The soil that is excavated will be laid in dumps in the pre-mined areas. And this is one of the pictures of that. This is the overview of navally lignite mines. And even though mining is a profitable sector, it leads to a lot of problems as it makes the land unsuitable for habitation, construction, it destroys the aesthetic beauty, it kills almost all this micro and the macrofauna, and it disrupts the normal soil profile and severely and drastically affects the soil physicochemical properties. So listed here are some of the possible solutions like topsoiling, addition of organic amendments like animal manure and other sawdust and biochar, and we have phytoremediation, usage of phytoremediating plants for removing soil contaminants. And then revegetation is a common strategy, and followed by recreation. So my research doctoral thesis lays emphasis on the revegetation portion, where hardy tolerant casuarina species along with the plant growth promoting rhizobacteria was tried. And so 5 objectives were laid for this doctoral thesis. And the first objective is isolation of rhizobacteria from the lignite mines. Second objective is evaluation of PGPR traits and phytochemical traits of the isolates. And third one is screening of selecting 2 or 5 potent PGPR isolates based on the characterization. Fourth objective is preparation of a carrier-based inoculum for pot culture experiment. And fifth objective is carrying out the pot culture experiments with Casuarina junguniana and organic amendments like prismid and farmyard involved the collection of soil and plant samples from the navally lignite mines. Mine 1 and mine 1A of navally lignite mines was visited, and isolation of rhizobacteria from plant samples collected from the mines. So a total of 25 rhizobacterial isolates were collected and subjected for studies like evaluation of PGPR traits and qualitative phytochemical analysis. And based on these studies, 5 potent PGPR isolates were selected and subjected for identification, antibacterial assay, antifungal assay, characterization studies, optimization studies, total phenolic content and gibberellic acid content. From the above studies, 2 isolates were screened and were subjected to pot culture experiments for a period of 9 months using the hardy and tolerant tree crop Casuarina junguniana, and with the design factorially completely randomized design with 20 treatments, each containing 10 replications and a total of 200 plants. And before and after the commencement of the pot culture experiments, soil parameters were assessed, and finally plant growth parameters were also assessed. This is the site mine 1A and mine 1 and mine 1A where the plants were collected. It is an open cast mine involved in the extraction of lignite. This is the overview of mine soil dumps from where plant samples were collected. Plant and soil samples were collected from different ages of plantation. Fresh overburden, 1-year-old plantation, 3-year-old, 5, 7 and 35-year-old plantations. And collection of meteorological characters were also recorded during the time of sampling, that is December 2014 and July 2015. And the collection of plant samples were done from all the ages of plantation. And the common plant that is used for revegetation in mines is the Leucanal lictocephala, that is the common name subabul, the nitrogen fixing tree. So hence that plant was selected for isolation of rhizobacteria, and all other plants found in the mine area was also collected. And these are the physicochemical analysis of soil used listed are all the parameters that were tested according to standard procedures. Isolation of rhizobacteria was done by decimal dilution technique. Samples opposed the roots of the common plant subarbul and other plant species, and sampling 2 sampling period during which all the samples and soils were collected. And all the a total of 25 rhizobacterial isolates were isolated and were subjected for plant of ammonia and hexane, heavy metal tolerance, and enzyme assay. Production of indole acetic acid was done according to the method described by Gordon and Weber, Sarkozy method. Production of siderophores was checked through 4 methods: chromazole sulfonate method described by Schwenn and Neylands, FeCl3 test, Neylands spectroscopy of siderophore described by Voce et al. Voce agar according to Eric Ramona et al. And production of ammonia was done using Messler's reagent described by Cappuccino and Sherman. Hexane production was described on glycine agar according to Lark. Determination of minimum inhibitory concentration was done for 3 heavy metals, mercury, chromium, and cobalt at the designated ppm levels. For mercury 20 to 100, for chromium 50 to 250, and for cobalt 50 to 200. All the isolates were streaked on nucleic agar amended to these plates and observed for growth. For enzyme assay, 3 enzymes were checked. The isolates were checked for the production of 3 enzymes: amylase, gelatinase, and cellulase, according to standard procedures. Amylase was checked on starch agar, gelatin liquefaction was observed, and production of cellulase on carboxyl cellulase agar. And qualitative phytochemical characterization for the carbohydrates, proteins, alkaloids, glycosides, phenols, flavonoids, and gums and mucilages were checked for all the 25 rhizobacterial isolates according to the standard procedures listed here. And based on these 2 characterization studies, 5 from among the 25, 5 isolates were screened and subjected for further analysis, like total phenolic content, gibberellic acid content, and identification. Total phenolic content was done according to Kamiketa et al. Gibberellic acid production was done according to procedure described by Boro et al. And the identification of isolates were done by preliminary test and by confirmatory test 16 as rRNA sequencing, and the GenBank accession numbers for the 5 isolates were also obtained. Antimicrobial assay for all the 5 cultures were done according to agar-well diffusion method, and the 4 bacteria were used, and the 8 fungal pathogens were checked. In seed germination assay, the paper towel method described by Zhu et al. Was checked, and all the parameters like percent germination, germination index, root and shoot length, fresh weight, and biomass were checked. In characterization studies, 4 characterization studies were undertaken: FTIR, TLC, HPLC, and gas chromatography. For all these studies, ethyl acetate extract, supernatant extracted 3 times with ethyl acetate, was used for the study. TLC analysis was performed on pre-coated TLC plates with the appropriate solvent system for IAA and GA. For phenols, the standard gallic acid used with appropriate solvent system, and the RF value was calculated and compared with the respective standards. For HPLC analysis, it was done according to Sharma et al. With appropriate standards and mobile phases. Gas chromatography and mass spectrophotometric analysis was also done with ethyl acetate extracts. And optimization study according to the method described by Kumari et al. For 4 carbon sources, 4 nitrogen sources, 5 pH levels, and L-tryptophan levels 0.2 to 2% levels. In pot culture experiment, factorial completely randomized design was undertaken with the 2 selected isolates, NLF and NLJ, along with 2 organic substrates, 2 levels of organic soil, and it was subjected to pot culture experiment at a field site. The tree crop was selected because it has a wide range of utility and application. It's an evergreen perennial, it's a nitrogen fixing tree, it has a symbiotic relationship with the actinomycete Frankia, and it is hardy and tolerant, and hence it's very well suited for mine soil reclamation. And as listed here, you can see it has high calorific value, it burns even when it is green. So the farmers can actually make use of it, and hence the plant was selected. It has lots of, the pulp is very pliable and it's used for paper making, and it has lots of medicinal properties. And it's used as a predominant wind break In intercropping and in agroforestry, it can be taken up for intercropping. So this is the experimental setup. The first row contained no organic substrates. It contained only the PGPR, NLF and NLJ. Second row and third row contained varied level of press mud and PGPR. Third and last two rows contain farmyard manure and varied levels of PGPR2. Carrier PGPR was applied with the help of a carrier material. Lignite was used as the carrier material. Bioinoculum was prepared according to the standard biofertilizer preparation, and all the bags received 8 kg of soil along with the designated amounts of PGPR and organic substrates. At the end of the 9th month, all parameters were assessed. For 200 plants were maintained. The initial plant and soil analysis, all the soil parameters were checked at the beginning of the pot culture experiment. Sapling survival percentage was checked. And at the end of the 9th month, all the soil, plant and biochemical parameters like shoot length, DBH, DCH, chlorophyll, carbohydrate, proteins and antioxidant enzyme like catalase, peroxidase and glutathione reductase activity was checked. This is the method for checking the measurement of shoot length at varied intervals, 90 days after planting, 180 to 270. Measurement of DBH and DCH was done with using vernier calipers. Chlorophyll content was done according to DMSO method. Carbohydrate estimation was done by Hedge and Hofreiter method. And for all the protein and antioxidant enzyme, common and standard procedures were followed as described here. So after 9 months, the soil parameters were again analyzed according to standard procedures, and all the data were statistically analyzed with ANOVA, student t-test and DMRT using SPSS version 23. So starting with, it's a navally lignite mines situated in Kadalur, 3 hours dive towards the south of Chennai. And these are the meteorological characters recorded at different 2 sampling periods. And these are the physico-chemical characters of mine soil initial analysis. As you can see, the bulk density of the 1 year, 5 year and 7 year old dump is above 1.5 undesirable level, which indicates high degree of compaction. And highlighted are the soil nutrient values, which are found to be very low according to the soil rating chart supplied by TMA. And these are the results of the enumeration of rhizosphere bacteria, and you can see the 35-year-old plantation had the maximum numbers, and it is also observed that the numbers slowly increased with the increasing age of plantation. And 25 rhizobacterial isolates were obtained, and they were prefixed with NL standing for navally lignite. Bulk density plays a major role in soil characteristic because high degree of compaction severely limits the rooting depth and low water holding capacity and low microbial activity, and the results are supported by mosaic and particle. And pH of all the dumps, 1 year, 5 year and 7 year, they are all found to be slightly above neutral. This could be due to the present nature of the parent bedrock of NLC, that is calcareous sandstones and limestones. So therefore the pH was slightly above neutral. And Singh and Ansari have suggested that the pH of the mine soil can vary between 2.6 to 7.74. And the soil nutrients in the mine soil was found to be extremely low. It's evidently because of the high compaction of the soil, low microbial growth, low water holding capacity, and other adverse conditions. And similar results of low nutrient levels were also described by Bushia and Karatori et al. At different mines. The rhizosphere population study slowly increased with increasing age of plantation. This is also supported by Lee et al. And Vector et al. Who also said that the older reclaimed soils has more numbers than the freshly laid overburden. And this is the evaluation of PGPR traits starting with indole acetic acid. They did not produce any high AA. And this graph shows the top maximum producer of IA was NLJ with 1 or 2 μg per ml. And CLP test also. And in Neelan's spectrophotometric assay, it was determined that all the siderophores belong to the hydroxylate group. And in estimation of siderophore units, NLF showed the maximum value, 24%. And this is the round the colonies, which is indicator of siderophore production. This is the results of FECL3 test. And this is the result of Neelan's spectrophotometric assay. The peak at 420 nanometers is suggestive of the presence of hydroxylate type, not of catechol and carboxylate. All the isolates showed peak brilliant portability. And production of ammonia, 72% of isolates showed ammonia production, 44 of them showed positive result for HCN. With regard to the cobalt tolerance, cobalt was toxic than the chromium, and hence the ppm level was low. For 16 isolates it was 150 ppm, and for 9 isolates it's 100. And chromium was the least toxic, being the MIC was found to be 300 ppm for almost all the isolates. This is the result for ammonia production. Heavy metals, MIC of chromium at various ppm. With regard to mercury, only one isolate was able to tolerate up to 80 ppm of mercury, that is NL9, and the results of cobalt at various ppm. And this is the result for enzyme activity. 80% of the isolates showed amylase production, and whereas 56% of them showed gelatin liquefaction, and none of them exhibited cellulase activity. The results for amylase and gelatin liquefaction test. And qualitative phytochemical analysis, 76 rest of them, around 7 isolates showed the presence of carbohydrates, and flavonoids and gums and mucilages were completely absent, and alkaloids, fetal production of alkaloids were shown by a few isolates. Phenols were produced by 52% of these isolates. So our results are in accordance with the findings of Kumari et al. Also showed that the bacillus subtilis can produce 137 mg of IAA, and similarly, Jennifer and Gassi et al. Have supported the siderophore production by bacillus species. In production of ammonia, Bhattacharya and Sharma et al. Have also indicated that this BGPR isolates can produce ammonia and HCl. In the present study, cobalt and mercury was found to be the most toxic, which is supported by Liu et al., who said cobalt tolerance can be up to a ppm of 1000 by bacillus species. In enzymatic activity, similar results were obtained by Al-Khatami et al., who said that PGPR can exhibit amylase, gelatinase, and cellulase activity. And on the right side, there are supportive evidence for the presence of and production of various phytochemicals like alcohol, alkaloids, ketones, and butanol, and 1,3-butanediol and proteins. And based on the above two characterization, PGPR and phytochemicals, 5 isolates, namely NLF, NLJ, NLK, NL9, and NL13, were selected for further study, moving to maximum IAA, siderophore, enzyme, and heavy metal toleration. And these are the 5 potent PGPR isolates, F, J, K, 9, and 13. And they were subjected for further study. Total phenolic content ranged from 3 to 17 gallic acid equivalents, and amount of gibberellic acid ranged from 74 to 84 mg per ml. And they were subjected for identification, and these are the results for the preliminary biochemical characteristics. All the 5 isolates were found to be gram-positive and motile, and based on these biochemical characters, they were identified up to the genus level as bacillus. And the 16S rRNA sequencing confirmed them to belong to Bacillus subtilis, Brevibacillus borstellensis, Bacillus amyloliquefaciens, Lisinibacillus fusiformis, and Bacillus cereus, and the listed here are the GenBank accession numbers. And this is the phylogenetic tree of the isolate NLF, NLJ, NLK, NL9, and NL13. And these 5 isolates were subjected for antimicrobial assay with 4 bacteria, and among the 5 isolates, NLF and NLK had a competitive edge over the other 5 rest of the isolates. They showed maximum zone of inhibition against selected bacteria. And these are the results for the antimicrobial assay. Maximum zone of inhibition was shown against bacillus species. And the similar trend was followed in antifungal activity. 8 fungal species were subjected for the study, and NLF and NLK again showed greater degree of inhibition when compared to the other isolates. And these are the results. And the maximum zone of inhibition was obtained for Rhizopus, and Mucor species was not inhibited by any of the isolates. And in seed germination assay, all the isolates had a significant germination, root and shoot length, fresh weight, and biomass. And these are the results for the seed germination assay, and the germination percentage was very poor in control, almost only 50%, whereas the rest of the isolates had 92%. Results for seed germination. These are the supportive results for supportive documents and research findings for the total phenolic content in gibberellic acid. Phenolic acid content production was reported by Singh et al. And Sharma et al. And Pandya and Desai have reported gibberellic acid production by bacillus species. All the 5 isolates that were screened belonged to bacillus. So this can be due to they are non-fastidious in nature, and they are abundantly present in the rhizosphere region, and they can quickly colonize the rhizosphere. That's the reason why all 5 isolates were belonging to the bacillus species. And Hakim et al. And Saladin et al. Have also suggested that this PGP are associated with the roots of many plants. In antimicrobial assay, the inhibition may be due to because of the production of many phytochemical substances, which is confirmed by the GCMS and FTIR analysis. And Lichtenberg and Kamilova and Zhu et al. Have suggested that PGPR can produce a wide variety of allelochemicals and some antigenic substances like zwittermycin, canosamycin, gluconic acid, and 1,3-butane and hydrogen cyanide. And because of these compounds, the antimicrobial assay results can be justified. And seed germination assay, the increased shoot length and the percent germination was predominantly due to the production of phytohormones, because IAA and gibberellic acid, they are implicated in root, stem and internode elongation, and it's called a rooting hormone. So, and the results are such as supported by Konopka et al. And Atkinson et al. And the characterization studies, these are the results for the FTIR analysis of all the 5 isolates. And these are the FTIR spectrum of the standard indole acetic acid and standard gibberellic acid. And these are the functional groups that are present in the FTIR spectrum. All these functional groups are suggestive of the presence of various substances, especially phenols, indoles, and other allelochemicals. Especially the H-bonded OH stretch at 3,400 centimeter is suggestive of indole groups and other phenolic groups. And the development, this is the thin layer chromatography for IAA and phenols. The pink colored spots on the coated TLC plate is confirmatory of the presence of IAA, and the bluish black colored spots on the right side is confirmatory of the presence of phenol, and the RF value corresponded with the standards. And these are the results of the HPLC analysis of the isolates F and J. As you can see, there are 2 sharp peaks in both the isolates NLF and NLJ at 1.4 and 2.09, which corresponded with the retention times of the standard IAA and gibberellic acid, thereby confirming the presence of IAA and GA in the NLF and NLJ. And this is the HPLC for phenols. As you can see, NLF shows a retention time near 3/3 minute, which is corresponding to the standard gallic acid, and there is no peak in NLF, NLJ, which suggests that there is no phenol production in NLJ. And these are the supporting documents. Alvarez, Mohit, and Harikrishnan et al. Have similarly obtained pinkish spots corresponding to IAA production, and bluish black spots on TLC sheets confirming the presence of phenolic compounds. And the HPLC Mayo et al. Have suggested that the retention time corresponded with it can be comparable to the standard and authentic IAA. And this is the results for the GCMS analysis. The compounds that are listed here, octadecanoic acid, hexadecanoic, aristotropic, all of them can be implicated in antifungal activity, antimicrobial activity, and antioxidant activity. And this is the chromatogram of NLF. And this is the bioactive compounds present in NLJ. The octadecanoic acid is a potent signal-inducing molecule in plants with responses to stresses from the phytopathogens. And all other compounds can be implicated in antifungal and antimicrobial activity. This is the GCMS spectrum of NLJ. And optimization studies and pot experiments. Optimization was done for 4 carbon sources, among which dextrose was found to be the optimal carbon source for both the isolates F and J. And in nitrogen sources for NLF, sodium nitrate was found to be optimum, and in NLJ, ammonium sulfate was found to be optimum because they showed maximum IAA production. In optimization studies for pH levels, for both the isolates, neutral and near neutral pH was found to be optimum. For NLF it's 7 and NLJ it is 7.5. And optimization studies for L-tryptophan concentration, for NLF, 0.8% of tryptophan was found to be optimum, and for NLJ, 2.2% was found to be optimum. In NLF, after 0.8, the production of IAA slowly declined and reached to a minimum at 2%. In the present study, dextrose was found to be optimum for both the isolates. It's evidently because for most of the bacterial isolates, dextrose or glucose is the preferred carbon source. Only in the absence of dextrose, other carbon sources will be utilized. And these results were supported by Chandra et al. And Kumari et al. Have obtained similar results for nitrogen source optimization. She has observed that ammonium sulfate as the optimum source. And for pH, Veerasamy et al. Has described the optimum pH as 7 for Bacillus Kumari et al. And this is the layout of the pot experiments, completely randomized design, a total of 200 plants. And the preparation of bioinoculum, lignite is used as the carrier material. Right side is the PGPR mixed with the lignite. So initial analysis of the soil indicated that the pH is above slightly neutral and the available soil nutrients were low and the bulk density was very high, 1.9. The sapling survival percentage for all the treatments except the control, which is 80% at 1 month of transplantation, and later throughout the 9 months of study, the control plants started to die one by one. So this is the effect of PGPR on the shoot length. The treatment T17 showed the maximum shoot length 275 cm at the 9th month of plantation. You can see evidently the increase, a massive increase in the shoot length when compared to the control plants. All the treatments showed huge diameter at collar height and diameter at breast height, and you can see that the control and the T1, T2 and T3 did not even reach the breast, and the maximum value was obtained for T5 and T10. This is the results for effect of various treatments on chlorophyll content. The treatment T8 showed the maximum value. This augmented shoot length is because of the application of PGPR and the combined application of PGPR along with farmyard manure and press mud, because organic amendments can significantly increase the growth and the shoot length. And even in the treatments T1, T2 and T3 that did not receive any organic amendments that received only PGPR, even though they have also shown a statistically significant increase in the shoot length, thereby suggesting that the PGPR could have supplied all the phytohormones and the other nutrients. And this is the results for the effect of treatments of carbohydrate content of cladodes. So all the treatments had a significant increase over the control, the maximum being T15. This is the effect of treatments on the protein content of cladodes. Again, over the control, rest of the treatments showed significant increase, maximum being the T11. And these increase in the protein and the carbohydrate content is evidently due to the increased nutrient supply through the farmyard manure and the press mud, and the increased mineral nutrient efficient uptake of the nutrients, translocation and utilization of nutrients in all the treated ones. These results are in accordance with the finding of Pandey et al. And the situation reversed when it came to the antioxidant enzyme activity, because the control plants had the maximum catalase activity than the rest of the plants, as it's seen in the graph. And similar trend was also observed for ascorbate peroxidase activity, the control plants exhibiting the maximum units than the rest of the treatments. This is due to the stress that the control plants were undergoing. This can be inferred as the control plants were subjected to defend against the stress caused by the reactase and more superoxide dismutase and peroxidase and glutathione reductase. So this explains the higher levels there. And in the treated plants with T1, T2, T3 and PGPR inoculation,
the levels were very high and the stress was effectively alleviated. And the results of Mesamaran and Satya et al. Are supportive of this finding. This is the result of the various treatments on the physicochemical parameters. As you can see, the pH was always slightly above neutral because the farmyard manure has a pH of 8. So in all the treatments without the application of farmyard manure, this could be due to the decreased growth of casuarina because casuarina is known to reduce the soil pH. Bulk density was found to come down from an undesirable level 1.8 to 1.5, clearly due to the addition of the organic amendments and PGPR. This is the effect of the treatments on the available nutrients. If you could see, the blue color is the available nitrate nitrogen. The nitrate nitrogen, even though it showed a significant increase over the control, the increase was not massive or exorbitant. But when compared with regard to available phosphorus and potassium, when compared to the control, there was a massive 10-fold increase in the available phosphorus and available potassium results in PGPR NLF and PGPR NLJ and NLF and NLJ as a consortium. So the available phosphorus and exchangeable potassium levels showed a massive increase. So this increase in the soil nutrient is evidently due to the PGPR inoculation, because PGPR can effectively mobilize all the nutrients. They can supply phytohormones, and the nutrients from the farmyard manure and the press mud has significantly increased the soil nutrient levels. And Wang et al. And Ashraf et al. Are in agreement with these present findings. And these are the results of the pictures of horticulture experiment at planting stage: 0 days, 60th day, 75th day, 90th day, 150 days, 180 days, 210, 240, and 270 days. Summary: the primary objective of the study is to identify a potent PGPR isolate to be used as a bioinoculant in mine soil reclamation, and therefore the lignite mine soil was studied. Its physicochemical properties showed high bulk density, poor NPK levels, showed a slightly above neutral pH, and the microbial population slowly increased with the increasing age of plantation. A total of 25 isolates were obtained from the roots of the plants found in mine area, and the PGPR traits were evaluated in tryptophan medium and tryptophan negative medium. And its for production, 16 isolates showed positive and 9 isolates showed negative for production. And 72% and 44% of isolates showed ammonia and HCl production respectively. The MIC was determined for chromium as 300 ppm, for cobalt 150 ppm for 16 isolates, 900 ppm for 9 isolates. In mercury, only 1 isolate was able to survive. In the enzyme assay, 80% of the isolates were able to produce amylase, 56 were able to liquefy gelatin, and none of them were able to produce cellulase. Various phytochemicals like carbohydrates, proteins, amino acids, alkaloids, phenols, and glycosides were present. Only 2 isolates showed feeble gums and mucilage. Flavonoids were completely absent. And these are the 16 as results of 16 as RNA sequencing and the GenPank accession numbers. And the antimicrobial activity. The isolate NLK showed maximum activity against bacillus and the fungi rhizome species. The characterization studies undertaken confirmed the presence of phytohormones and other allelochemicals in the isolates. In seed germination assay, all the 5 isolates exhibited remarkable increase in the root length, shoot length, percent germination, and germination index. In the optimization studies for NLF, dextrose, sodium nitrate, pH 7 and 0.8 L-tryptophan level is found to be optimum. In NLJ, dextrose, ammonium sulfate, 2% level of L-tryptophan and pH 7.5 was found to be optimum. And bioinoculant for 2 isolates were prepared using lignite as the carrier source, and these are the results of the pot culture experiment. And the factorial CRD was undertaken for a duration of 9 months with 25 and 50% pressed and farmland manure. And all the treatments showed significant increase in the shoot length, TCH, chlorofil, carbohydrate and protein content. Whereas the control plants showed high levels of catalase and antioxidase and other peroxidase and glutathione reductase activity. And the soil analysis revealed that there was increased levels of soil nitrogen, phosphorus, available phosphorus and available potassium in the treated plants compared to the control plant. Conclusion: successful restoration of degraded ecosystems such as mine soil dumps depend upon proper revegetation strategies, and the process can be hastened. The revegetation process can be hastened with the help or application of PGPR. The present study identified 5 potent PGPR isolates that proved to enhance the growth of the tree crop Casuarina genuina on mine soil. Findings from the present study reveal that Casuarina tree crop is an ideal tolerant crop that can establish on mine soil, which can replenish the soil nitrogen through nitrogen fixation and other methods. Addition of organic amendments like chestnut and farmyard manure had a cumulative effect on the successful establishment of saplings on mine soil along with PGPR. Seeding of the plant with PGPR inoculum brings out a healthy rhizosphere environment, which in turn can contribute to the restoration of the degraded ecosystem to near normalcy. The future scope, future studies can be undertaken for identifying site-specific growth-enhancing PGPR isolates in other similar degraded ecosystems. Development of suitable formulation of bioinoculum can be taken up. An ideal dosage of organic amendments can be done, because in the present study, quite high, 25 to 50% of organic dosage, amendment dosage was taken. And finally, the study can be extended to other species of Casuarina in similar ways. Thank you.
Now, the floor is open for discussion. Audience and faculty members, they have limited vision numbers, and please nowadays.
Casuarina is already having introduced bacteria. So what type of synergistic effect, whether it will have addition to the growth or what type of interaction you have found with this?
PGPR is not a symbiotic organism. It can effectively colonize the rhizosphere and give any kind of, the effect will be cumulative in addition to primary. So it will not have any inhibitory effect on the already existing symbiosis. So it will just add up to the, Frankia can fix only nitrogen, whereas PGPR can supply other nutrients like HCN production, phytohormone production, and other benefits can be supplied by PGPR.
Global warming and climate change. The only option is restoring the forest. We have to increase the vegetation cover, especially